There was no flat valley floor for cranes, no practical place for a forest of temporary supports. In the mountains of Sichuan, the route of the Gujin Expressway reached the Shuiluo River Gorge and confronted a problem that could not be solved by simply building upward from below. The terrain was steep, access was limited, and the bridge had to cross the void without turning the gorge floor into a conventional construction yard. So the structure had to grow outward from the mountains themselves. Two unfinished halves of a reinforced concrete arch advanced from opposite slopes, held in a temporary state by cables and towers, until they could meet above the canyon. That image is the key to the entire Shuiluo River Bridge. The completed bridge is impressive, but the most revealing moment is the one before completion, when the arch is not yet an arch at all. A finished arch is efficient because loads can flow through compression toward the foundations at both ends. An unfinished half-arch cannot rely on that closed geometry. During construction, each side behaves more like a giant cantilever reaching into empty space. The permanent structure therefore depends, for a time, on a temporary structural system that must control forces the finished bridge will never experience in the same way. The main span is 335 meters. It is a deck-type reinforced concrete arch, and technical literature on the project identifies the cable-stayed cantilever cast-in situ method as the defining construction strategy. The bridge was not designed as a single symmetrical object placed onto an indifferent landscape. The terrain and geology shaped the geometry itself. To reduce excavation of the mountain, designers adopted what the technical literature describes as a slope arch. The arch line on the Jinsha bank is 6.7 meters higher than on the Gujin bank. Even before construction began, the canyon had already written itself into the structure. That matters because mountain infrastructure is rarely only about span. A bridge has to connect to roads, tunnels, slopes, foundations, and working areas that already exist within a difficult topography. In a broad valley, engineers may have room for access roads, cranes, falsework, and temporary supports rising from below. Here, the problem was not simply that the gorge was deep. It was that the place where conventional temporary construction would normally stand was the least practical place to build it. The solution was to make the bridge carry the process of becoming a bridge. From both banks, crews constructed the main arch ring segment by segment. Formwork, reinforcement, and concrete moved outward as the unfinished arch extended farther from the rock. Temporary towers and cable systems stabilized the advancing structure. Those cables did not merely hold weight. They helped control geometry and internal forces while the concrete arch was still incomplete. Every new segment changed the balance. The farther each half reached, the more carefully the temporary system had to be managed. This is why the construction sequence matters as much as the final design. A completed bridge can be photographed as a single object. Construction is a chain of changing structural conditions. A cable force that is correct for one stage may not be correct after another segment is added. A small geometric deviation near the bank can become more significant as the cantilever length grows. Temperature changes can alter dimensions. Concrete properties evolve with time. The final shape can only be achieved if the temporary shape is continuously measured, predicted, and corrected. Monitoring therefore became part of the structure story. Survey instruments tracked alignment. Engineers followed stresses and deformation. Cable forces were adjusted as construction advanced. Technical work associated with the bridge specifically addresses design, construction, and monitoring as one integrated problem, because on a span of this scale, the unfinished arch is not simply a smaller version of the finished one. It is a different structural condition with different vulnerabilities. The material itself also had to match that demand. Project research includes work on C80 steel fiber concrete used in the arch ring context. The important point is not to turn that designation into a marketing claim about the entire bridge. It is to understand why high-strength concrete and fiber reinforcement matter in heavily stressed elements. controlling cracking, carrying high compressive demands, and maintaining reliable behavior through a construction sequence in which local stresses can be severe. The bridge's drama is not that one material is magically stronger than everything else. It is that material, geometry, temporary cables, and monitoring had to work as one system. There is another reason the arch form suits this landscape. Once closed, an arch redirects loads toward its foundations at the sides of the gorge. That allows the central void to remain open beneath the bridge. But this advantage only arrives after closure. Before that moment, the two halves are structurally incomplete. The most efficient final form creates one of the most demanding construction phases. That contradiction gives the project its visual tension. From one bank, a massive concrete rib reaches outward. From the other, its counterpart does the same. Between them remains a narrowing gap. Below is the gorge. Above and behind them, temporary towers and cables hold the geometry in a controlled balance. The scene looks almost finished, but structurally it is still waiting for the event that changes everything. In August 2023, the main arch ring reached closure. The last gap was not simply filled as if joining two pieces of pavement. The two halves had to be brought into a precisely controlled relationship so that the completed arch could begin working as a continuous structural system. Once closed, the path of the forces changed. What had been two cable-supported cantilevers became one arch spanning from mountain to mountain. The temporary system had done its job. The permanent structure could begin to behave as intended. Above the arch, the deck and its supporting elements completed the road level. The bridge is part of a much larger mountain corridor, where tunnels, viaducts, and steep alignments form a continuous response to the terrain. The Shuiluo crossing is the most dramatic moment, but it only makes sense as part of that route. Infrastructure succeeds when the spectacular object disappears into a journey people can use. By the end of 2023, the Gujin Expressway opened to traffic. Official project communication said the connection would reduce the journey between Gulin County and Longshan Town from about 90 minutes to roughly 10. That number explains why the bridge is more than a record-setting span. For the people who use the route, the engineering achievement is measured in ordinary time. Fewer switchbacks, fewer long detours, and a mountain crossing transformed into a direct connection. And that brings the story back to the canyon. It is tempting to describe bridges like this as victories over nature. But the Shuiluo River Bridge tells a more interesting story. The gorge was never removed. The slopes were never flattened into an easy construction site. The difficult geometry remained. Instead, the design accepted those conditions and changed the method. The arch grew from the cliffs because the ground below could not conveniently support the usual construction logic. Its alignment shifted with the terrain to reduce excavation. Temporary cable systems held an incomplete structure until it could become structurally whole. Monitoring linked every stage to the final geometry. High-performance materials were used where the demands were greatest. And the moment of closure turned two separate reaches of concrete into one continuous path. The canyon never became easier to cross. The cliffs never moved closer, and the river never offered a convenient place to build. What changed was the method. By allowing the arch to grow from the landscape that constrained it, engineers turned two isolated edges into one continuous road. The Shuiluo River Bridge is not a monument to ignoring geography. It is a monument to listening to it.